going to talk today about torque. So torque is defined as the rotational equivalent of force. So it's the force needed to cause an object to rotate. About a particular point. So if you have an object and it's sort of pivoting and you want to make it rotate, you want to push down on it, what you need to do is apply torque, which is the equivalent of force, but it's the force to make something rotate. Okay? So the symbol we will use for torque is tau. Funny looking T sign. The equation is torque equals F, which is the force, times D, which is the distance, times sine of theta. Okay? So we'll define those things. F is the force exerted. D is the lever arm, or we say this is the distance to the pivot point. So from the force to the pivot point, and theta is the angle between the force and the lever arm. Okay? And the units for torque will be newtons, that's force, times meters. That's the distance, so Newton meters. So when can torque be at its maximum value? Let's think about that. We'll say, how can we maximize torque? To maximize torque, let's look at the equation. What are some things we can do here to make this number bigger? Well, we can make the force bigger, obviously. We can increase the distance, so make the lever arm, it's the distance, bigger. Or we can make the angle, theta, close to 90 degrees because sine of 90 is the largest value, which is 1. Okay? Now, torques move in a circular direction. About the pivot point. If a torque causes counterclockwise rotation, then we consider that torque to be positive. So you have positive torque. We consider it positive. If a torque causes clockwise rotation, then we consider that torque a negative torque. Okay? So, let's do an example. Okay, so this example reads, a lever is used to lift a boulder. The fulcrum is placed 1.6 meters away from the end at which you exert a downward force. So the fulcrum is where it pivots. This is the pivot. Producing a torque of 400 Newton meters. If the angle between the force and the lever is 80 degrees, what is the applied force? Okay, so you sort of have a picture. You have your lever with a fulcrum, and we'll use a triangle to show the fulcrum, and you have a distance of 1.6 meters from the end where you apply a force on the fulcrum to lift the rock. Here's your boulder. Okay, so you apply a force downward to lift the rock. You're going to use the equation we just learned. Torque equals FD sine theta. Okay, we have the torque is right here, 400 Newton meters. So we'll plug that in for torque, 400. I'm looking for the force. What is the applied force? I have the distance from the fulcrum to the force is 1.6 meters, so times 1.6 sine of the angle 80. So please make sure when you do this, you are in degree mode. Always double check your calculator before you calculate. And then go ahead and do the calculation and come back and see if you got the right answer. Force is 253.86 newtons. Okay? So that's a simple example of how to use the torque equation. When you get back to class, we'll do more examples, some that are a little bit more challenging, and then we'll get into torque equilibrium. Okay? Thanks for watching.